Hey guys, so in this question, you have a rod of length L, which is uniformly charged, and this has the charge density lambda, and it's kept on a smooth horizontal surface. So this is your charge rod, which is uniformly charged, has the charge density lambda, so on and so forth. Your right end of the rod is fixed, and it's in contact with the vertical wall. A block of mass m and charge q is projected with a velocity v from a faraway point, and it is projected or it is given a velocity along the line of the rod only, so it's going towards the rod, right? So as you can imagine, there will be a repulsive force acting between these two. The rod cannot move towards right because the wall prevents it from moving. So this block will be experiencing a repulsive force, so this block keeps on slowing down, right? So the question asked over here is find the distance of closest approach between the block and the left end of the rod, right? So what is the closest distance your block will approach the rod is what we need to calculate in this question, right? Okay, so let's imagine this scenario, and the scenario will be your block of charge q and mass m is approaching this rod right now, right? And this rod is charged, it has linear charge density lambda, it has a length L. Okay, so the force which is acting on this block while it's moving is the electrostatic force, and this force will be a repulsive force. So you'll have a repulsive force acting on it this way, right? So at a certain instant, as it's moving, its velocity keeps on decreasing as it's moving. It initially had a velocity v. So as it keeps on moving, its velocity will be decreasing. So you'll reach an instant where its velocity will become equal to 0. And now at this instant, this block is closest to the rod. This block is closest to the rod. So let me assume the distance to be r. And this r is what we need to calculate over here. After this, the block will get repelled and the block will start moving backwards, right? Okay, so this is our condition for closest approach. When this block reaches or is at the closest distance to the rod, your velocity of the block will become equal to 0. And the force acting on this block during its journey from here to here is electrostatic force, which is a conservative force. So we'll be making use of conservation of mechanical energy over here, since electrostatic force is the conservative force. So we'll be writing initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy, right? So initial kinetic energy, we know that's equal to half mv squared. Initial potential energy, since this block is very far away from the rod, we can also guess that the initial potential energy value will be equal to 0. Final kinetic energy of the rod is also, final kinetic energy of the block is also equal to 0. We are relating it to the distance of closest approach, so that's a final position. And at that position, your velocity of the block will be equal to 0. So what will be your final potential energy, right? So for potential energy, these are not point charges, so we can't make use of kq and q2 by r as a formula. So the idea we'll be going with over here is we'll write q into potential due to the rod. We'll now calculate what will be the potential due to this rod at r distance away from it, right? So this is basically once again a question based on calculating potential only. So we'll now calculate what will be a potential due to the rod at a point which is located r distance away from the end of the rod. So how do we calculate that? So we need to calculate potential at this point P. This point P is located r distance away. So we'll say that this rod is made up of many point charges. So how do we select one point charge at a distance of x from point P? Let me select a dx portion. Okay, what is the value of charge you have on that dx? That dq will be equal to q by l into dx. So what will be a potential at point P? We'll say potential at point P is sum of potential to all the point charges. So that will be summation of all k into q by l dx. So we're using kq by r as a formula. This is your charge value. And how far away is this point P from this dq charge? This point P is at a distance of x from this dq charge. So k into q by l into dx by x is potential to one charge at that point. Potential to all the charges will be equal to summation of all of them. And what will be the limits of integration over here? Limits of integration will be from x is equal to r to x is equal to l plus r. Right, so this is an easy enough integration. K, q by l are constants. Integral dx by x will be equal to log x. So, and the limits are from r to l plus r. So this become equal to kq by l log of l plus r by r. Right? And now this is your potential to the rod at point P. So this will be a potential to the rod at this point. We'll now be substituting this in this expression. So if I substitute this in this expression right now, we'll get half mv squared is equal to q into kq by l into log of l plus r by r. Right, the unknown in this expression we need to calculate is small r only. So we'll have to solve this equation to solve small r. So let's solve this equation right now. So we have half mv squared is equal to kq by L, kqqq by L into log of, let me write it this way, log of 1 plus L by R. Right, so our unknown is small r right now, so you have small for small r. So let me shift these terms to this side and even logarithm to this side. So this will become equal to mv squared L by 2 kqqq is equal to log of 1 plus L by R. Then let me take exponential on both sides. So this become exponential of mv squared L by 2 kqqq is equal to 1 plus L by R. So L by R will become equal to exponential of mv squared L by 2 kqqq minus 1. So R will become equal to L divided by e power or exponential of mv squared L by 2 kqqq minus 1, right? So this can be written as, if I substitute k value, that is 1 by 4 pi epsilon naught, this will become equal to mv squared L 2 mv squared L pi epsilon naught by qq minus 1. So this R is what we needed to calculate, so that will be your closest distance of approach of the block from the rod, right? So this will lead to which answer? This will lead to answer number 2, right? Actually, I have to write capital Q in terms of lambda over here. So what will capital Q be in terms of lambda? Capital Q in terms of lambda will be equal to lambda into L. So that's all this question in terms of capital Q. So if I substitute lambda into L, L gets cancelled. So our answer should be 2 mv squared pi epsilon naught by lambda q. 2 mv squared pi epsilon naught by lambda q is what we end up with over here, right? So that will be option number B. So B will be our answer for this question. Hopefully this question makes sense. See you guys in the next question.